Hello everybody, I will start my today another coding practice. So today I will solve this question. Merge case sorted list. I think this is quite a famous question. Yeah, and I think I've solved it so many times. But I, pick up this question today again and solve this. Okay, so in this question, I'm given an array of k linked list. Each linked list is sorted in ascending order. Merge all the linked list into one sorted linked list and return it. Okay. So in this question, I'm given k linked list. It's a list, and each of them is sorted in ascending order. And I will merge all the linked list into one sorted linked list. Okay. So the input of this question is list of node. The node is the head of the linked list actually. And what I will return is the node. That's the output, which is the head of the merged linked list. Okay, so now for the constraint, k can be 0. So in that case, I think I will be given an empty list and I should return none because I don't have any head. Okay. Good. Okay, so let me think how I can solve this question. So let me think with some examples because I'm pretty sure of the question statement and what I will do. So let's say I'm given the linked list like this, and also the linked list like this. In this case, I should return the linked list like this. Yep. So this is the merged linked list. And I will return the head of this, which is node 1. Okay. Oh, by the way, the list can be empty, but each list is non-empty, I think. No, each list can be also empty. So it can be something like this. Yep. So in this case, obviously I don't have any node from this new, so empty linked list, so I just can forget it. However, as the edge case, in this case, I should return null. I don't have any node, so yeah, I should return null. Okay, let's see. So that being said, let me think of the algorithm. I think the brute force approach is that first we get node from this first linked list and also get nodes from the second linked list. And I sort all the nodes in ascending order. Then I connect each node. I mean, the first node should point to the second node. The second node should point to the third node in that way. So that's the brute force approach. But I'm pretty sure this would take n log n time, assuming that number of all the nodes is n. Yep. So picking each node takes O of n time, and then sorting all of them should take n log n time, and then connecting all of them take n time. So in total, it should take O n log n time. Yep. So I will think of the better approach. So when I have to think of the two linked lists, obviously, I just have to use the 2 pointers. However, in this question, there are 3 or more linked lists. In that case, actually I can use the 3 pointers, but the problem here is that how can I guess the smallest number? Node of the smallest number in these 3 pointers. So once I find it, I get that number for 3. Then, because I took it, I move this pointer. Then I will take a look at node 2, 3, and 2 and 3, and I find that 2 is the smallest number. So I pick this node, node 2. Then I will just move this pointer, and then now the 3 pointers point to 3 and 4 and 3. So definitely I should take node 3. Either of these 2 nodes is fine. So let me pick this one first. Yeah, and in that way. And once, for example, I run out of the first linked list, now it should be pointing to null. And when this is pointing to null, I just completely forget this first pointer because I, run out of the nodes. Okay, and as I said, the problem here is that how I can guess the smallest node from 3 pointers, or I should say k pointers. So definitely I can use heap, yeah, because Oh, and one more thing I have to make it clear is that after picking the smallest node, the next node value is inserted into the 3 pointers. 3 options. So there is a kind of getting the minimum one, and also a new element is popped in. Pushing. So it goes like finds the minimum number, then new number is inserted. Then I guess the minimum number again, and new number is inserted. It's the iteration of that. Does that make sense? I should use a mini heap. Okay, so I can say this question is the combination of k pointers and mini heap. Okay, so I think verbally I explained what I should do. So let me think how much time complexity it takes. So in total, I have to. Okay. Assuming that number of all nodes is n, the time complexity should be. So the number of times okay, the heap size is always k. So for pushing operation and also popping operation, each of them takes log a k time. And how many times I have to do it? So it's definitely the number of the total nodes, total number of the nodes, so it should be n. So this is the time complexity. Yep. And for space complexity, I need the k pointers and also heap whose size is k. Yeah, that's it. So it should be k. Okay. So now let me, start the implementation. And before that, because this question is a little bit complicated, I will outline the strategy in the written form. So for the variables, I will use the pointers. Then also I need heap, I think, because I cannot insert node into the heap. Yeah, I have to, if I think it was a heap of the nodes, I cannot specify how I should prioritize the popped out nodes. So I have to use the heap with this. It should be it's the heap of the tuple current value versus the next value and list index. Okay. I think I actually don't need this. Wait, do I need it? I think I don't even have to keep track of the pointers. I just have to push the, this. So from each linked list, I put this here, and every time I pop out the smallest element from here, which means the smallest value, node with the smallest value. And then what I would do is I create the merged list, and also I think of the current pointer in the merged list. So I will move this current pointer in the merged list, which should be always the tail. Yeah. Then yeah, I think this works. So basically, the next node, k next node should be in the heap. So in that way, I can guess the smallest next number and that node. And once I get that node, I push it, I connect it to the merged list. Then I push the next node of the popped out node to the mini heap. Okay. And if there isn't a node after the current popped out node, I just skip pushing in, because there's no node from that linked list. Okay, so let me implement this. I quickly wrote it down. Okay, so I start the implementation. So firstly, I will implement merge head. I put the pseudo head here. Then I will initiate the mini heap. This should be the list. Yep. Okay. No. Yeah, so this is the list of the tuple and used as mini heap. Okay, then from here I do the iteration. So Oh, sorry, I forgot to do something. I have to heapify this node first. Node rest first. Yeah. Then I come back to line 53. So I basically pop out the picked node. So this picked node should be connected to the end of the merge rest. Okay. Then what I should do is I yeah, I push this next node into the heap, mini heap. Okay. Now it's okay. So what I should do next? Basically, I return the merged head dot next because the current merged head is a pseudo node. I need to return the next node of the pseudo head. Okay. Oh, and in line 56, I forgot to do something. Yeah, if next node is not none, I push into the mini heap. Okay. Oh, and one more thing I have to do is I have to move the merge tail pointer. Yeah. Good. So one thing I'm a bit caring is where is the last node dot next pointing to? Obviously, the last node in the merge list should come from, the last node of any of the linked list. So now it's pointing to none. So it's okay. Good. I just wanted to confirm it. Okay, so now let me work through my code with some example. I think of the very, easy example. Oh, wait, but let me think. What if the length of the list is 0? In that case, I just return none. It's okay because merge head is there, but I don't do any connection, make any connection from on this merged, pseudo head because in line 57, next node's length begins with 0. Yep. So in line 65, pseudo head dot next is none is returned. Okay. And one more case. I have some linked list, but any one, some or all of them is empty linked list. Oh, so in that case, I have to think with this in line 54. I have to add this, 15 net. If the head is none, I don't want to include it into the next nodes. So in this way, let me think that the given list has only one linked list, and that one linked list is actually an empty linked list. In that case, in line 54, the head is now none. So now next node is initiated with empty array. So in this case, completer is the same as the last example I told you. None is returned. Okay. I confirmed these two cases. So now let me think of the very easy example like this. Okay, so in this case, so first three merged head is pointing to no pseudo node. Then merged tail is not here. Okay. Now I initiate the next node. So I will take a look at each linked list, and if head is not known, yep, which is true for each of them, I initiate the next nodes with head.var and head. Okay. Yep. So for this is okay, and I heap q.heapify this. Good. Now in line 66, while this is non-empty, firstly I pop up this one, and now pick node is node 1. This is okay. Then merge tail.next should be node 1. Okay. Then next node is equal to pick node.next, which is node 2. So next node is now node 2. Okay, let me move this. So in line 69, first three, I move the merge tail. Yep. Then next node is pick node.next is now node 2. Oh, and this is not known. So I push this into the heap. This is inserted. Okay, so let me change this to say 1.5. Sorry, I want to make this inserted between one and I don't want to change node value 1 or 2, so I make it 1.5. It doesn't matter. Okay. No, sorry, let me change it to on the second, so I will change the 3. So now 1, 3 is inserted. Okay. Oh, actually, next node was wrong, so it should be now this like this. Okay, and now node 2 is inserted, and I come back to line 66, and now I pop out this one. And now pick node is node 2. And merge tail dot next is pick node. So this should be now node 2. And merge tail is moved by 1. Yes. And next node is pick node 2 dot next, which is none. And because this is none, I don't do anything, and I go back to line 66. Now I have the last one, which is popped out. So pick node is now node 3. So merge tail dot next is next node 3. And merge tail is now moved. Then in line 70, next node is pick node dot next. So it's now none. So in line 71, I don't do anything. And I go out of the while loop. And in line 74, I return merge head.next with, which is node 1. Okay, sounds good. So I run my code. Heap q.heapify next. Oh, unfortunately, this doesn't work. So what should I do? Okay, let me change my idea. So instead of this, um, I will use the tuple of head value and linked list index. And I will have the next nodes list of the next nodes, node object as another data structure. And every time I pop out the element and I get the linked list index, I take a look at that node. Yep. I think this naming was so good. So let me use it. And also okay, let me rename it in this way. Next node's list and next node's heap. So, okay. And as I said, instead of this, I enumerate this. So I get the list index here. So, and I put list index here. Okay. Good. So in line 65, this is okay. And the problem is in line 68, when it popped out, I get the picked list index. So picked node should be the next node list. Picked list index. Yep. Okay. Then this is okay. Yep. Now what I should do is if next node is not none. Oh, I think I can just put it into the next node's list. I think updating this with none in the case when we could know this the tail. I think this is okay, and I think we should do it. So yep. Then in line 77, if next node is not none. Oh, sorry. This is this. Next node is not none. I push into the heap. So wait a minute. This should be list index. And this should be next node to the power. Yep. Okay. Looks good. Okay, let me quickly rename this to just list index because it's a bit redundant. Yep. Okay, looks good. I run my code again. And I pop it from heap. Wait, what's the problem with this? Oh, sorry, next node's list should be, I haven't initiated this. So basically, I do similar thing like this, but I'm interested only in the head. So wait, even if the head is known, I should put it to this list. Yeah, so actually this is completely the same as the given list. Okay. Now accepted. I submit my code. Good, accepted. Okay, so I quickly wrap up my today's practice. So in this video, I solved the question, merge case-ordered rest. And for this, in this question, I'm given the list of linked list, and my task is to merge all the linked list into one sorted linked list and return the head of it. Yep. And for that, I showed the, some examples, and I found out that I should, have the heap of the next nodes from each linked list. Then I that should be stored in the mini heaps, so I can always get the you know minimum valued node from that mini heap. So that's a linked list. No, that's a node I should use next. Connect to the tail of the merged linked list. And then after merging it to the tail, I think of the next node of that picked node. Then I push it into the mini heap because it's the next option I can choose. Okay. Yeah. So I do iterate this until I run out of the nodes in every linked list. And one kind of thing I noticed while implementing is that I cannot push, you know, I cannot include node in the mini heap because mini heap cannot compare to nodes. So instead of that, as a workaround, I push the head value and the list index into the heap, and I store the next node list of the node object in another data structure, which is named next node list. So yeah, with this workaround, I could make my solution work. Okay, I finished my coding practice with this.